In human history, gold has never been seen as an ordinary metal. People have viewed it as if it belongs somewhere higher than this world. In the 15th century at Cusco in the Inca Empire, the Coricancha temple was once covered with giant gold plates that reflected sunlight, to the point where the Spanish conquerors said the entire temple seemed to be glowing. Around 1300 BC, the ancient Egyptians believed that gold was the flesh of the god Ra, and placed it around the mummies of the pharaohs as a form of immortal matter. The Greeks told the story of King Midas turning everything he touched into gold, as if this metal carried supernatural power. The strange thing is that civilizations thousands of kilometers apart all shared the same belief that gold came from the sky. And the most interesting thing is that they may have been wrong about the gods, but right about the true origin of gold. Because if Earth did not create gold, then where was this metal actually born? And to understand that, first you have to understand what a star really is. Most people look up at the night sky and think stars are just giant balls of fire hanging in space. But in reality, every star is a continuous battle between two opposing forces. Gravity tries to crush all the matter inward, while nuclear fusion tries to push energy outward. Our sun exists because those two things are temporarily balanced. In the sun's core, where the temperature is about 15 million degrees C, hydrogen continuously fuses into helium and releases energy according to Einstein's famous equation. That very reaction creates the light that shines on your face every day. But here is the really strange part. Over millions and then billions of years, stars do not just create helium. Larger stars continue to create carbon, oxygen, neon, silicon, and many other elements through increasingly extreme stages of fusion. In fact, most of the carbon in your body was created inside stars that died long before the solar system was born about 4.6 billion years ago. You are literally made of stardust. And many people think gold was created in the same way. But physics sets a very strange limit at iron. Iron has an atomic number of 26, and the remarkable thing is that fusion only releases energy up to the point of creating iron. After that, everything reverses. If you try to fuse iron into heavier elements, the reaction begins to consume energy instead of producing it. Think about that for a moment. A giant star lives thanks to fusion, but the moment its core contains too much iron, that machine is almost out of fuel. It is like an airplane engine suddenly stopping thrust while flying. Gravity immediately wins. The star's core collapses at a terrifying speed in just a few seconds. And this is the problem for gold. Gold has an atomic number of 79. It is much heavier than iron. That means ordinary stars simply cannot create it. Even the sun, with a mass of about 2 times 1030 kilograms, is not hot enough or violent enough to create even a single atom of gold. To create gold, the universe needs temperatures of billions of degrees C and neutron densities greater than anything that exists in the sun's core. In other words, gold is only born when physics is pushed to the most extreme conditions that nature can create. That is when the story begins to leave familiar things like ordinary stars and enters the realm of truly strange physics. Because to create gold, the universe must use a mechanism completely different from ordinary stellar fusion. Fusion is like building a wall by stacking bricks one by one in a fairly stable order. Hydrogen into helium, helium into carbon, carbon into oxygen. But gold is different. Gold is too heavy. You cannot reach it by that normal path anymore. Nature has to use something close to nuclear violence on a cosmic scale. Physicists call that mechanism rapid neutron capture, or the R process. The basic idea is that an atomic nucleus begins absorbing neutrons at an extremely fast rate. Then, before that nucleus can stabilize or decay, it continues to absorb new neutrons, and more, and more. This happens in such a short time that the entire nucleus is almost submerged in a continuous neutron storm. Imagine you are trying to pile thousands of bricks onto a building, while its foundation has not even had time to stabilize. That is almost what the universe is doing, with matter at the atomic level. But here is the really hard part. You need an almost absurd amount of neutrons for this to happen. The neutron density required for the R process is billions of times greater than inside ordinary stars like the sun. Just creating such an environment is already a terrible problem. And that is why gold is so rare. Carbon is created everywhere in the universe. Oxygen too, silicon, magnesium, calcium, all are born quite commonly in large stars. But gold is not. Gold only appears when nature is pushed to nearly out of control conditions. That is also why I have always found the story of gold much more interesting than the way people usually think about it. When you look at a gold ring, you are looking at the product of one of the most extreme processes that physics has ever created. In the 1950s, scientists like Margaret Burbidge, Jeffrey Burbidge, William Fowler, and Fred Hoyle began building the first modern picture of stellar nucleosynthesis. They tried to explain how the universe creates the entire periodic table. Their famous B²FH paper in 1957 almost completely changed the way physicists viewed the origin of matter. And one of the most important things they realized was that very heavy elements like gold, platinum, or uranium could not be created in the ordinary way inside stars. Physics simply does not allow it. To go beyond iron, you need something far more violent. Something that can submerge matter in neutrons at a terrifying rate. That is why physicists began looking at the most violent places in the cosmos. Supernovae are a natural candidate. A supernova can shine brighter than an entire galaxy for a few days. In just a few seconds, it releases more energy than the sun will produce in its entire lifetime of about 10 billion years. Shock waves race through space at tens of thousands of kilometers per second. Matter is crushed and ejected throughout the galaxy. For many decades, many physicists believed that was where gold was born. And honestly, that made sense. But then an even stranger possibility began to emerge. Something that sounds more like science fiction than actual astronomy. Neutron stars. Just the name sounds unusual. Think about this for a moment. You take a mass nearly equal to the entire sun, about 2 times 10^30 kilograms, and compress it down to the size of a city about 20 kilometers wide. Matter is crushed to the point where electrons and protons merge into neutrons. Gravity is so strong that light passing by is bent by space-time. A teaspoon of neutron star material could weigh about 1 billion tons on Earth. What fascinates me most is that human intuition almost refuses to accept it. Our brains evolved to throw rocks and avoid predators on the savannah. They were not designed to understand neutron stars. But physics does not care about human intuition. Nature continues to do completely ridiculous things out there in the universe. And the more they studied neutron stars, the more physicists began to suspect that this could be where gold was really born. Not in ordinary stars, not in familiar fusion reactions, but in environments where matter is pressed to the final limits of reality. What made physicists begin to suspect neutron stars as the place where gold is created is that there is almost nowhere else in the universe extreme enough to do it. A neutron star is actually the leftover core after a giant star dies in a supernova explosion. Imagine a star with a mass 10 or 20 times that of the sun living for millions of years through nuclear fusion reactions. It creates layer after layer of elements like a giant reactor in space. But eventually it reaches iron. And right at that moment, the entire system collapses. In just a few seconds, gravity crushes the star's core with a level of violence that is almost impossible to describe. Pressure increases to the point where electrons and protons are forced together into neutrons. The matter you are familiar with completely disappears. The spaces between atoms disappear. What remains is a giant block of neutrons compressed to an unbelievable degree. The idea of neutron stars was first proposed by Walter Baade and Fritz Zwicky in 1934, just a few years after the neutron was discovered by James Chadwick. And honestly, at that time the idea sounded more like science fiction than real physics. But the more they calculated, the more physicists realized the math seemed to lead exactly there. An object with a mass nearly equal to the sun, but compressed to a size of only about 20 kilometers. Stop for a moment and think about that. The sun is about 1,400,000 kilometers wide. But a neutron star containing nearly the same amount of matter is only as wide as a city. The human brain almost refuses to imagine this. Your intuition says it cannot exist. But the universe does not care about our intuition. Nature continues to do completely absurd things out there. A teaspoon of neutron star material could weigh about 1 billion tons on Earth. Not 1 million tons, 1 billion tons. If you somehow brought a teaspoon of neutron star material to Earth, it would pierce through the planet's crust, much like a bullet through air. The gravity on the surface of a neutron star is about 200 billion times stronger than Earth's gravity. If a human stood on that surface, which of course cannot happen, they would be crushed into something thinner than an atom in a fraction of a second. In fact, even light no longer moves normally near a neutron star. Einstein pointed out that gravity is actually the bending of space and time, and neutron stars bend that structure to the point where light passing by is pulled off course. If you stood close enough to a neutron star, the universe around you would literally look distorted. Time also begins to work differently. What always fascinates me is that neutron stars lie almost at the boundary between the physics we understand and the physics we do not yet understand. You are looking at matter in a state that laboratories on Earth can almost never recreate. In fact, we are still not entirely sure what it looks like inside a neutron star. Some physicists think there may be superfluid neutrons deep inside. Others think matter is compressed into quark form. When physics is pushed to the extreme, reality begins to become very strange. But for many years, neutron stars remained only an idea on paper. Physicists believed they existed, math said they should exist, but no one had seen them directly. Then in the late 1960s, something very strange happened at Cambridge. A graduate student named Jocelyn Bell Burnell was analyzing radio signal from space when she discovered an extremely regular series of pulses. The signal repeated so precisely that at first some people even joked that it might be a signal from aliens. But scientists quickly realized this was not aliens. It was a neutron star spinning extremely fast, a pulsar. An object only a few tens of kilometers wide, but spinning dozens of times per second, and emitting beams of radio waves like a cosmic lighthouse. That discovery almost confirmed that neutron stars really exist. And the more they studied them, the more physicists realized this could be the perfect environment for the gold creation process. Because if you want to create gold, you need a terrible neutron density. And neutron stars are almost the most neutron-rich thing the universe has ever created. But here is the truly terrifying part. One neutron star is strange enough. The horrible thing happens when two neutron stars begin orbiting each other. Imagine two objects with masses nearly equal to the Sun, but each only about 20 kilometers wide, locked in a gravitational dance lasting millions of years. At first they orbit quite slowly. It might take hours for a complete orbit. But then something very strange begins to happen. According to the general theory of relativity that Einstein published in 1915, massive objects curve space and time around them. And in 1916, Einstein realized that if giant objects move strongly enough, they not only bend space and time, but also create ripples that propagate through the very fabric of the universe. Physicists call them gravitational waves. The interesting thing is that for many decades, even Einstein was not entirely sure those waves were real, because their effects were too small. But with two neutron stars, things are no longer small. As they orbit each other, they continuously shake space and time. And each time that happens, the system loses a bit of energy. That energy does not disappear. It leaves the star system in the form of gravitational waves traveling across the universe at the speed of light. Think about that for a moment. Two objects millions of light years away from us can shake the very structure of reality. As energy is gradually lost, the orbit of the two neutron stars begins to shrink. They spin faster, then faster still. The distance between them decreases from thousands of kilometers to a few hundred kilometers, then a few tens of kilometers. In the final stage, they orbit each other hundreds of times per second. Their speed approaches the speed of light. And this is the part where human intuition almost stops working. You are looking at two superdense blocks of matter, each hundreds of thousands of times heavier than Earth, hurtling around each other at hundreds of thousands of kilometers per second, while bending space and time as if the universe has become a soft fabric being twisted. The entire process lasts millions of years. But the final moment happens in just a fraction of a second, when the two neutron stars collide. The temperature rises to billions of degrees. Pressure far exceeds any conditions inside ordinary stars. Matter no longer behaves like familiar matter. Neutrons are torn from the star's surface and ejected into space at tens of thousands of kilometers per second. What happens next is almost the most perfect environment that nature can create for the gold creation process. The neutron density at this point is so high that atomic nuclei are submerged in a giant neutron storm. The rapid neutron capture process occurs so violently that heavy elements begin to appear almost immediately: gold, platinum, uranium. The rarest elements in nature are born amid that terrible chaos. What always makes me laugh is that humans often think of gold as a symbol of stability, luxury, and eternity. But its true origin lies in one of the most violent events the universe can create. In just a few seconds, nature can create more gold than all the gold humans have ever mined in the entire history of civilization. Think about that. The wars, the fallen empires, the gold rushes that sent hundreds of thousands of people across oceans. All that gold is just an extremely tiny amount compared to what is created in a single neutron star collision. What obsessed physicists with this idea is that everything in the math seemed to fit perfectly. The neutron density matched, the energy matched, the nuclear decay rates matched. Almost the entire picture made sense. But at the time I was alive, this was still only theoretical speculation. We had never directly seen two neutron stars collide, never directly detected gravitational waves, never witnessed the gold creation process out there in space with our own eyes. All physicists had were equations, indirect signals, and the intuition that nature seemed to be pointing in that direction. And honestly, that is one of the things I like most about science. Sometimes you are forced to follow very faint traces to try to understand something that's almost beyond the imagination of the human brain. You look at a few weak radio signals, a few equations on paper, a few elements in meteorites, and from that you begin to realize that the gold ring on a person's hand may have been born from the collision of two dead stars billions of years ago. Physics sometimes leads us to places where imagination can almost not keep up. If you look at a supernova, you are looking at one of the most violent explosions in all of nature. A giant star lives for millions of years and then suddenly collapses in just a few seconds. After that, its entire outer layer is blasted into space with so much energy that for a short period of time, the explosion can shine brighter than an entire galaxy containing hundreds of billions of stars. Think about that for a moment. A single object shining brighter than an entire galaxy. This sounds more like mythology than physics. But the universe really does things like that. Humans saw supernovae long before they understood what they were. In 1572, the astronomer Tycho Brahe observed a new star appearing in the sky. It was so bright it could be seen even during the day. What made that event important was not just the explosion itself, but its philosophical consequences. At that time, many Europeans still believed the sky was perfect and unchanging. Celestial bodies were supposed to be immutable. But then suddenly a new star appeared where there had been nothing before. Tycho Brahe recorded the event extremely carefully and realized this object was very far from the moon. That meant the sky was not unchanging. The universe could change. Stars could die. And honestly, that was one of the first moments when humans began to understand that the cosmos was not a perfect, motionless machine, but a place full of violence, birth, and destruction. Later, physicists realized supernovae were not just beautiful. They were also giant element factories. When the star's core collapses, shock waves race through the outer layers of material at terrifying speeds. Temperatures rise to billions of degrees. A huge amount of neutrons is created in an extremely short time. And that is exactly what made physicists start thinking about the rapid neutron capture process. In such an environment, atomic nuclei can continuously absorb neutrons and then turn into much heavier elements. A portion of the periodic table was born in those violent moments. Fred Hoyle was one of the first to truly build the modern picture of this process. What I like about Hoyle is that he viewed stars not just as bright objects in the sky, but as giant chemical machines quietly creating the matter of life. Before that, many people did not really understand how elements were created. But Hoyle, along with many other physicists, began to point out that carbon, oxygen, calcium, and many other elements were actually cooked inside stars and then scattered into space when the stars died. This leads to an idea that I have always found extremely beautiful. The calcium in your bones was once created in an ancient star explosion. The iron in your blood once lay in the core of a giant star. You are literally the product of cosmic explosions. But the hardest question is still gold. Supernova models show they can create very strong neutron flux. They certainly create many heavy elements. But whether they are extreme enough to create most of the gold in the universe is something no one is certain about. And this is what is interesting about science. Many people think science works like a book full of clear answers. In reality, most of the time scientists live in a state of uncertainty. They have hypotheses, they have equations, they have a few pieces of data, but they do not yet know whether the overall picture is correct. For many decades, physicists continuously compared theory with increasingly accurate observations. They studied the light spectra from supernovae. They analyzed the amount of heavy elements in ancient meteorites. They calculated neutron flux, decay rates, and the physical conditions in collapsing star cores. And the more they did that, the more complex the story became. Some data seemed to say supernovae were enough to create gold. Other data suggested perhaps an even more extreme environment was needed. That is why neutron stars began to become increasingly attractive to physicists. But in the 1980s, when I was still alive, no one could say for sure what the main source of gold was. We knew gold had to be created in extremely violent events. We knew it required temperatures of billions of degrees and enormous neutron densities. But the universe is often much more complex than human intuition. Maybe supernovae create some gold. Maybe neutron stars create most of it. Maybe both participate. That is exactly the beauty of science. You do not start with absolute certainty. You start with curiosity. Then little by little you try to force nature to reveal its secrets. But whatever the final answer is, one thing is almost certain. Every gold atom on Earth was born in the most violent events the universe has ever created. Most people look at a gold ring and think it is something dug up from the ground. But in reality, its story began long before Earth existed. Our solar system formed about 4.6 billion years ago from a giant cloud of gas and dust in space. That cloud was not new material. It was the remnants of countless generations of stars that had lived and died before. Among them was stardust from supernovae and possibly the most violent neutron star collisions in the universe. That means the gold atoms in a person's ring existed before the sun itself. Think about that for a moment. Before Earth had oceans, before there were dinosaurs, even before the sun began to shine, those gold atoms had already been wandering in space between the stars for millions, even billions of years. And what fascinates me most is that every one of those atoms had once gone through conditions more violent than anything that has ever happened on Earth. They had been submerged in temperatures of billions of degrees. They had been hurled through space at terrifying speeds after star explosions. They had existed in regions where neutron density was so high that matter behaved in ways that are almost impossible to imagine. Then finally, after a nearly unimaginable journey, they became part of the cloud that created the solar system. About 4.6 billion years ago, that cloud began to collapse under the force of gravity. Most of the material concentrated at the center and formed the sun. The rest flattened into a rotating disk of dust and gas around the young star. From that disk, planets began to form. Small dust particles collided with each other, stuck together, and gradually grew over millions of years. Eventually they formed celestial bodies hundreds and then thousands of kilometers in size. The young Earth also appeared that way. But Earth at that time was nothing like the planet you live on now. It was almost a molten hell. Temperatures were so high that most of the surface was just a giant ocean of liquid rock. Meteorites constantly slammed into the planet. Volcanoes erupted everywhere. Everything was chaotic and violent. And gold, along with iron, nickel, and many other heavy elements, was mixed into that molten mass. This is where the story takes a very strange turn, because gold does not behave like most other elements. In planetary chemistry, gold belongs to the group of iron-loving elements. That means when iron began to sink into the young planet, gold tended to follow it. Imagine you are dropping extremely heavy drops of metal into a giant ocean of molten rock. Under the force of gravity, the heavier material begins to sink deeper. And that is exactly what happened with Earth. In the first tens of millions of years, the planet gradually differentiated into layers. Lighter elements rose to the top to form the crust and mantle. Iron, along with many heavy elements, sank to the center to form the planet's core. Gold followed that process. This leads to a very interesting paradox. If gold was mixed into Earth from the beginning, then most of it should have ended up deep in the planet's core rather than on the surface where humans could mine it. In fact, just looking at the mass of Earth's core, you will realize this planet could contain far more gold than all the gold humans have ever mined. But almost all of that disappeared deep underground, thousands of kilometers beneath our feet, billions of years ago. And that is where the story becomes even stranger. Because if gold had already sunk into Earth's core very early, then where did the gold used by ancient civilizations to make crowns, god statues, and coins actually come from? That very question led scientists to one of the most interesting ideas in the entire history of planetary science, the late veneer process. That process is actually one of the most important things that ever happened to the young Earth. Planetary scientists call it planetary differentiation. It sounds very technical, but the basic idea is quite simple. When Earth was still a giant ball of molten rock, the elements began to separate into layers, according to their mass and chemical properties. Lighter materials rose to the top. Heavier materials sank to the bottom, and gold belonged to a group of elements with an extremely important property. It is an iron-loving element. That means gold mixes very well with liquid iron. In chemistry, scientists call such elements sidophiles. When Earth's core began to form more than 4.5 billion years ago, molten iron sank gradually toward the center of the planet like giant drops of metal falling to the bottom of a lava ocean. Gold followed that process. Imagine the entire planet as a giant glass of liquid, slowly separating into layers under the force of gravity. The heaviest materials gradually sank deep down. And because gold dissolves so well in liquid iron, most of the gold that once existed on Earth was pulled down into the planet's core very early. This leads to an extremely strange conclusion. Most of Earth's gold is not in gold mines, it is not in banks, it is not in jewelry, it lies deep beneath our feet, almost completely unreachable. Geochemists today believe that more than 99% of Earth's gold is in the planet's core at a depth of about 3,000 kilometers. Think about that for a moment. All of human history has almost only accessed the tiny bit of gold dust left on the surface. The vast majority of this planet's real gold disappeared into the interior billions of years ago. What always fascinates me is that Earth's core is actually far stranger than people imagine. The temperature there can reach from 4,000 to 6,000 degrees C, nearly as hot as the surface of the sun. The pressure is so great that matter behaves in very unusual ways. We live on the thin outer crust of a sphere that is almost hell inside. And the funny thing is that humans have almost never gone deep into their own planet. In the 1970s, the Soviet Union began the Kola Superdeep Borehole project in hopes of drilling as deep as possible into Earth's crust. After nearly 20 years of work, they reached a depth of about 12 kilometers. That sounds very deep, right? But compared to Earth's radius of about 6,300 kilometers, it is almost like you pricking the skin of an apple with a needle and thinking you have discovered what is inside it. We have never come close to Earth's core. We have never directly seen the place where most of the planet's gold lies. And perhaps we never will. This leads to an idea that I have always found very interesting. Human civilization is actually living on an extremely thin layer of material on the outside of the planet, while most of the real resources lie forever out of reach. Most of Earth's gold is almost permanently locked inside the molten core. You cannot dig down there. You cannot drill down there. You cannot withstand the temperature and pressure there. This makes the existence of gold on the surface an even greater mystery. Because if almost all the gold had sunk into the planet's core billions of years ago, then where did the gold that the Egyptians used to make Tutankhamun's mask, the gold that the Inca Empire covered the Coricancha temple with, or the gold sitting in the ring on your hand actually come from? That is when the story begins to move into an even stranger chapter. If most of Earth's gold had already sunk into the planet's core billions of years ago, then the gold remaining on the surface must have come from somewhere later. That is when geochemists in the 20th century began to develop a very interesting idea called the late veneer. The basic idea is that after Earth's core formed and pulled most of the gold deep, inside, our planet continued to be bombarded intensely by meteorites and comets for hundreds of millions of years afterward. In other words, gold on Earth's surface may not be what was left over from when the planet formed. It may be extra delivery from space afterward. This leads us to an extremely violent period in the history of the solar system that astronomers call the Late Heavy Bombardment, which occurred about 4 billion years ago. If you could turn back time and look at the solar system then, it would not look like the quiet place we see today. The young planets continuously collided with giant rock fragments left over from the solar system's formation. Meteorites slammed into planetary surfaces almost non-stop. Our moon still bears the scars of that period. The giant craters on the moon's surface are actually like a fossil record of the solar system's first era of violence. Earth was also attacked that way, but wind, water, plate tectonics, and geological activity have erased almost all traces of that ancient time. What is interesting is that this very curse may have saved future human civilization, because the meteorites that slammed into Earth did not just bring rock. They brought heavy elements like gold, platinum, and iridium. In other words, after Earth swallowed nearly all its gold into the core, the universe sent more gold back from space. This sounds more like mythology than science, but the chemical evidence increasingly points in that direction. In fact, most of the gold humans have ever mined may originate from ancient meteorites that struck Earth billions of years ago. Think about that for a moment. A lump of gold sitting in a bank vault today may once have been part of a meteorite flying around the young solar system before slamming into this planet. It once drifted between planets in the darkness of space for millions of years before becoming part of Earth's crust. What always makes me laugh is that people often think gold is something that belongs to Earth, while in reality most of the gold near the surface may be visitors from outer space. Scientists began to notice this when studying iron meteorites. Many meteorites contain much higher amounts of gold and other siderophile elements than ordinary rock on Earth's crust. That suggests these objects have a chemical composition similar to the material that once sank into the planet's core. And then an even more interesting type of evidence appeared from tungsten isotope studies. This is the part where science becomes more like criminal investigation than physics. Geochemists cannot turn back time to look at ancient Earth. They have to reconstruct the past using tiny chemical traces left in rocks. Tungsten is especially useful because some of its isotopes are directly related to the process of core formation. When scientists compared the tungsten isotope ratios in Earth's mantle with ancient meteorites, they discovered something very strange. The chemical composition of the mantle shows that after the core had formed, Earth still received additional metal-rich material from outside. In other words, the chemical evidence seems to confirm that a large amount of gold on the planet's surface was delivered after the core formation phase. What I have always loved about science is that sometimes you can discover billions of years of history just from a few atoms inside a small piece of rock. Humans have never seen Earth 4 billion years ago. We have never witnessed those meteorites slamming into the young planet. But chemistry still remembers. The atoms still carry traces of the past. And from those tiny traces, scientists began to realize something that is almost poetic. Cosmic violence did not just create gold. It also delivered gold to humanity. That also explains why humans have been obsessed with gold for thousands of years. A very large part of it lies in its rarity. Almost every civilization that has ever existed has viewed rare things as symbols of power. But gold is special in that its rarity is not created by local geology or economic history. It originates directly from the physics of the universe. To understand that, think about what has to happen to create a single gold atom. First, you need a giant star to live and die. Then you need extreme conditions with terrifying neutron density. It may require a supernova or a neutron star collision. Then those gold atoms have to survive a journey through space for millions of years. After that, they have to be mixed into the cloud that form the solar system. Then an extremely small portion of them has to avoid sinking into Earth's core. And finally, they have to concentrate enough in the crust for humans to find them. When you look at that entire chain of events, gold's rarity starts to make complete sense. In fact, it would be much stranger if gold were everywhere. The average gold content in Earth's crust is only about a few parts per billion. That means in 1 ton of ordinary rock, the amount of gold present is often smaller than a speck of dust the human eye can see. That is why gold mining is so difficult. In many modern gold mines, people have to crush and process tons of rock just to obtain a few grams of gold. Think about that. You dig up an entire mountain, grind it into powder, use chemicals to separate each rare metal atom just to get enough gold to make 1 ring. And the funny thing is that after all that effort, Most of the gold on Earth still lies deep in the planet's core, where we can never reach it. That rarity is exactly what has made gold a store of value for thousands of years. If gold were as common as iron or aluminum, no one would care about it. But gold is not like other common elements. Iron is produced in huge quantities in large stars. Aluminum also forms relatively easily in the universe's ordinary physical processes. Gold does not. Gold requires extremely rare and violent events. That is why almost every civilization has viewed gold as something close to the divine. The Romans used gold to display the power of their empire. The Egyptian pharaohs covered their tombs with gold because they believed it symbolized immortality. The Spanish Empire crossed oceans to find gold in the New World. And even in modern times, when humans have electronics, nuclear energy, and spacecraft, gold still holds a very strange place in human psychology. Central banks still hold gold as a symbol of stability. In times of economic crisis, people often turn back to gold, as if our ancient brains still believe this metal carries a special kind of safety. What I have always found interesting is that most of that value ultimately stems from physics rather than economics. Economics only reacts to the rarity that the universe created billions of years earlier. If star explosions created gold more easily, the entire economic history of humanity would probably have been different. Wars over gold might never have happened. Empires might not have hoarded gold as a symbol of power. Even human currency might have developed in a completely different direction. That alone is enough to make me laugh. The history of civilizations is actually influenced by nuclear reactions that occurred in dead stars long before Earth existed. But here's the part I like the most. Humans often think rarity is an economic concept. In reality, it is first and foremost a cosmological concept. Gold is rare not because humans decided so. Gold is rare because nature almost never creates it. Every gold atom is the product of an extremely unusual chain of events, spanning billions of years. There is one question that I have always loved extremely, because it sounds simple, but leads straight to the strangest part of modern physics. Why is gold yellow? It sounds like the kind of question a child would ask, right? But in reality, this is one of the most beautiful examples of how nature acts much more strangely than human intuition. Most metals are silver-colored. Aluminum is silver. Iron is silver. Platinum is almost white silver. So why is gold different? Why does it reflect that characteristic warm light instead of silver, like almost every other metal? Many people think the answer lies in ordinary chemistry, but no. The real answer lies in Einstein's theory of relativity. And what I have always found wonderful is that you can see the effect of Einstein with your own eyes every day without realizing it. To understand this, first you have to think about the electrons in a gold atom. Gold has an atomic number of 79, meaning it contains 79 protons in its nucleus. That nucleus carries a very large positive charge, pulling the surrounding electrons with extreme force. The electrons in the innermost shells begin to move at terrifying speeds, close to half the speed of light. And this is when relativity starts to enter the story. According to Einstein, when an object moves extremely fast, its properties change, effective mass changes. Space and time no longer work in the familiar way. That is not only true for spacecraft or galaxies, it is also true for electrons in a gold atom. Because gold's electrons move so fast, their orbits and energy levels are distorted by relativistic effects. Here is the really strange part. In most metals, electrons absorb and reflect light in a way that makes the entire light spectrum look almost white silver. But in gold, the relativistic effects change the energy spacing between the electrons. The result is that gold absorbs the blue part of the spectrum more than normal. When white light shines on gold, the blue part is retained more, while the red and yellow parts are reflected back to your eyes. That is why gold is yellow. Think about that for a moment. The ring on your hand has its characteristic color because the electrons inside its atoms are moving so fast that Einstein has to get involved in the story. Without the theory of relativity, gold would almost certainly be silver-colored like most other metals. This fascinates me enormously because most people think relativity only concerns black holes, the speed of light, or distant galaxies. But no, it is deciding the color of a piece of jewelry in your pocket. This is exactly what I love about physics. The most abstract ideas ultimately connect directly to the everyday world in completely unexpected ways. And gold is not the only case. Mercury also has many very strange properties due to relativistic effects. Most metals are solid at room temperature, but mercury is a liquid. Part of the reason also comes from its electrons moving extremely fast around a heavy nucleus. Those relativistic effects make the bonds between mercury atoms weaker than normal. The result is that this metal melts at a very low temperature. That means even in high school, humans have actually seen the effects of Einstein without realizing it. And the more I think about this, the more I see that reality is much stranger than the way the human brain intuitively pictures it. a lump of gold, is not just a beautiful yellow block of metal. Its color is determined by the deepest structure of space and time. The equations Einstein used to describe the universe on a large scale are also quietly affecting the motion of electrons inside every tiny gold atom. This creates a very strange feeling that I have always liked in science. Everything in the universe seems connected at a much deeper level than appearances suggest. From the neutron-star collision that creates gold, to relativity deciding its color, the whole story is like a chain of connections stretching from the most violent events in the universe to the small ring on a person's hand. And the best part is that nature has no obligation to be understandable to our intuition. The human brain evolved to hunt on the African savanna, not to understand electrons moving near the speed of light. Yet somehow, we can still use mathematics and curiosity to see through the ordinary appearance of the world and realize that even the color of gold is a consequence of the deepest laws of the universe. The universe is often much stranger than human intuition ever expected. There is another reason humans have loved gold for thousands of years, and this may be even more important than its rarity. Gold almost never dies. Think about that for a moment. Almost everything around you is slowly being destroyed. Iron rusts, copper turns green, silver tarnishes. Even stone is worn away by wind and water over time. But gold is different. Gold almost never changes. It is one of the least chemically reactive metals that nature has ever created. If you leave a bar of iron in the air long enough, oxygen and water vapor will begin to react with it. The iron atoms lose electrons and form iron oxide. That is what we call rust. But gold almost does not care about that. It does not react easily with oxygen in the air. It is not easily corroded by water. It almost ignores its surroundings. This creates a very strange feeling for ancient humans. They saw everything gradually decaying over time, but gold stayed bright and shiny from one generation to the next. Gold objects buried with Egyptian pharaohs more than 3,000 years ago can still shine brightly when unearthed in the 20th century. Think about that. Empires fall, cities disappear, languages die, but gold still looks almost exactly like the day it was first crafted. It is not hard to understand why many civilizations began to view it as a symbol of immortality. The ancient Egyptians did not understand atomic structure or modern chemistry, but they were smart enough to notice something very important. Gold seemed to not die. In a world where everything ages and decays, gold looked like something that stood outside of time, and in reality, that stems from the way gold's electrons are arranged. This is the part where chemistry and physics begin to connect with human psychology in an extremely interesting way. Chemical reactions occur when electrons of atoms interact with each other. Some elements very easily give or accept electrons, so they react strongly. Sodium, for example, reacts violently with water. Iron is easily oxidized. But gold holds its electrons very tightly. Gold's electron structure makes it much less willing to participate in chemical reactions than most other metals. In other words, gold is one of the laziest elements in the periodic table when it comes to chemistry. That sounds funny, but that very laziness made gold seem almost immortal in the eyes of ancient humans. I have always thought this is one of the most beautiful things in science. What ancient civilizations viewed as divine often stems from very deep physical and chemical laws of nature. The Egyptians did not know about electrons. The Incas did not know about atomic structure, but they observed the world around them very carefully. And they realized gold was different from all other metals. It was not easily destroyed. It did not change color. It did not disappear under the effects of time. That is why gold appeared in religious rituals, tombs, and symbols of power almost everywhere in the world. Not only because it was rare, but because it seemed to transcend the normal laws of destruction in nature. That also explains why gold became the perfect material for currency for thousands of years. If you used iron as money, it would rust. If you used copper, it would change color and corrode gradually. But gold stays almost unchanged over time. An ancient Roman gold coin can still exist thousands of years later with its shape almost unaltered. That is what civilizations needed for storing value. A material that is both rare and almost perfectly durable. And what I have always found interesting is that all of this ultimately comes back to the physics of the atom. Human empires, religions, wars, and economies have been influenced by the way electrons move around the nucleus of an element born from ancient star explosions. When you think deeply enough about that, the boundary between astronomy, chemistry, and human history begins to disappear. It is all connected. Gold is not beautiful just because humans decided it is beautiful. Nature created a material that is rare, stable, and almost indestructible by time. And then the human brain reacted to those properties by attaching divine meaning to gold. This is what I have always liked about science. It does not destroy the wonder of the world. It just shows you why the world is so wonderful. Physics and chemistry have accidentally created the metal that is almost perfect for human mythology. What I have always found interesting is that even the greatest minds in history have been obsessed with gold. Isaac Newton is the perfect example of that. Most people remember Newton as the discoverer of gravity, the builder of classical mechanics, and the inventor of calculus. But there is another part of his life that many people hardly know about. Newton spent many years secretly researching alchemy, and not just casual curiosity. He wrote hundreds of thousands of words about the philosopher's stone, about the transmutation of metals, and about mysterious formulas that alchemists had passed down for centuries. In fact, the amount of notes Newton left on alchemy is greater than what he wrote about physics. That sounds extremely strange to us today, because we tend to divide the world into science on one side and the mystical on the other. But in the 17th century, that boundary was not so clear. Scientists of that time were still trying to understand what matter really was. They did not yet know how atoms worked. They did not know electrons or protons existed. They did not have the modern periodic table. In their eyes, the idea that one metal could turn into another was not unreasonable at all. If lead and gold were both matter, why could one not be turned into the other by some secret process? That was the greatest dream of the alchemists. They believed there existed a special substance called the philosopher's stone that could turn cheap metals like lead into gold. But what is interesting is that their goal was not just to get rich. For many alchemists, gold represented the perfection of matter. It was rare, beautiful, did not rust, and seemed immortal. They believed that if they understood how to create gold, they could understand the deepest secrets of nature. Newton was drawn into that idea for nearly his entire life. He studied ancient texts full of mysterious symbols, tried to decode chemical formulas written in language that was almost like code. What I like about this story is that it shows how powerful human curiosity is. Even the person who built the foundations of modern physics could not resist the mystery of gold. But here is what the alchemists did not know. Gold is not just a purer version of lead or copper. Each element is determined by the number of protons in its atomic nucleus. Gold has 79 protons. Lead has 82 protons. That means if you want to turn lead into gold, you cannot just mix chemicals or heat the material in the ordinary way. You have to change the atomic nucleus itself. In other words, you have to change the deepest structure of matter. And no one in the 17th century could imagine that. They did not know protons existed. They did not know what an atomic nucleus was. They did not know that matter is actually mostly empty space with tiny particles moving inside. This creates a very funny feeling in the history of science. The alchemists were almost completely wrong about the mechanism, but they were right about a very profound point. Lead really can be turned into gold, just not by magic or secret chemistry, but by nuclear physics. This creates one of the most interesting paradoxes of modern science. The people viewed as mystical were actually pursuing an idea that was ultimately partly correct from a physical standpoint. Of course, they could not do it with the technology of their time, but their dream was not as completely unreasonable as people usually think, and I have always felt there is something very human in this. Newton was not drawn to gold just because of its value. He was drawn to the mystery of matter, to the question of how nature works at the deepest level. That is also exactly what drove modern physics later. From alchemy to quantum mechanics, there actually exists a very strange connecting thread. Both began from the same human obsession, understanding what matter really is and whether we can transform it. What I have always liked about science is that it shows human curiosity often comes long before understanding. We ask questions before we have the tools to answer them. The alchemists did not know about protons, neutrons, or nuclear reactions, but they correctly sensed that matter could change at a level deeper than its appearance. And many centuries later, nuclear physics finally began to prove that it was true. It took hundreds of years after Newton's time for humans to truly understand how matter is structured. In the 20th century, physics finally began to look inside the atom. Scientists discovered that atoms are not solid little balls, as many people once imagined. They have an internal structure. At the center is a nucleus containing protons and neutrons, while electrons orbit at relatively very large distances. And then one extremely important thing was realized. What determines which element something is not its color, mass, or hardness. It is the number of protons in the nucleus. Gold has 79 protons. Lead has 82 protons. That means if you want to turn lead into gold, you have to change the number of protons in its atomic nucleus, not change the outer chemistry, not mix in some secret substance. You have to intervene directly in the deepest structure of matter. This is exactly where nuclear physics enters the story. What I have always found interesting is that when humans truly understood the atom, the world began to become much stranger rather than simpler. We discovered that matter is not immutable, as intuition once thought. Atoms can be split, nuclei can be transformed. One element can truly become another element if you change its internal structure. Medieval alchemists would probably have gone crazy if they heard that. And to do this, physicists built machines that looked more like science fiction than ordinary technology. Particle accelerators. Basically, they are devices that use extremely powerful electric and magnetic fields to fire tiny particles at speeds close to the speed of light. Those particles then collide with atoms with enormous energy. Imagine you are trying to change the structure of a watch by firing a tiny bullet into it at terrifying speed. That is almost what physicists do with atomic nuclei. And then the strangest thing happened. Humans actually turned lead into gold, not by magic, not by the philosopher's stone, but by nuclear reactions. When some protons are knocked out of a lead nucleus, that atom can become gold. This sounds almost like a joke in the history of science. Alchemists had pursued this dream for thousands of years, and modern physics finally said, yes, that is actually possible. But here is the funniest part. The process is completely useless economically. The energy required to create an extremely small amount of gold is many times greater than the value of that gold. You can create gold in a laboratory, but it costs vastly more than digging it out of the ground. That completely shattered the alchemist's dream of getting rich. They were right about the final goal, but completely wrong about the mechanism. And honestly, I have always thought that is a beautifully perfect example of how science progresses. Humans often correctly sense that nature has something deeper than its appearance. But it took many centuries for us to understand the real mechanism underneath. What I like most about nuclear physics is that it shows the periodic table is not a random collection of elements. The entire periodic table is actually the result of nuclear structure. Simply change the number of protons and you change the element. One different proton and matter becomes something completely different. That means the diversity of the material world around us ultimately comes from tiny changes in atomic nuclear structure. When you think deeply enough about that, reality begins to feel very strange. Wood, stone, water, gold, uranium, or the human body are all built from the same few basic particles, differing only in how they are arranged. And that is what I have always loved about modern physics. It continuously destroys the feeling that the world is divided into completely separate things. Everything is connected at a much deeper level. Lead and gold look completely different to the human eye, but at the nuclear level they are only a few protons apart. That makes the boundary between elements far less absolute than humans thought for thousands of years. And perhaps the most beautiful thing in this entire story is that gold ultimately connects two worlds that seem unrelated. On one side is ancient mythology, alchemy, and the dream of turning ordinary metal into divine metal. On the other side is quantum mechanics, nuclear physics, and the giant accelerator machines of the 20th century. Both began from the same ancient human question: what is matter really, and can we transform it? What makes the story of gold truly astonishing is that its influence does not stop at physics or astronomy. An element born from the most violent explosions in the universe ultimately helped shape almost all of human history. Almost every major civilization was influenced by gold in some way. Not just because it is beautiful, but because humans gradually came to see it as a symbol of power, stability, and order. Around the 7th century BC, the Lydians in Asia Minor, in what is now Turkey, began creating the first gold coins in history. This was one of the most important turning points in civilization that many people almost never think about. Before that, trade usually relied on bartering goods or items of local value. But gold changed everything. Because it is rare, durable, easily divisible, and almost indestructible over time, it became the perfect store of value. Suddenly, humans had something that almost every society agreed was precious. And when that happened, trade networks began to expand more than ever before. Ships crossed the Mediterranean. Caravans crossed deserts. Empires began to accumulate gold the way modern societies accumulate energy or technology. The Romans understood this very well. The Roman Empire was not built only by armies, it was built by gold. Roman gold coins paid soldiers, funded wars, and maintained power over a vast territory stretching from Britain to the Middle East. When you look at an ancient gold coin, you are not just seeing precious metal, you are seeing the fuel of an entire empire. What I have always found interesting is that civilizations almost unconsciously responded to gold's physical properties. It does not rust, so it creates a feeling of eternity. It is rare, so it symbolizes power. It shines, so it connects with the sun and the divine in the human mind. It is almost as if the human brain is programmed to be fascinated by gold. But perhaps nowhere does this show more clearly than in the 16th century Spanish Empire. When Europeans arrived in the New World, they became almost obsessed with gold. Stories of the golden city of El Dorado spread across Europe like a collective fever. The Spanish saw gold not just as wealth, but as the key to global power. What is sad is that for the Inca or Aztec, gold had a very different meaning. It was often a sacred material connected to the sun and the gods. But for European empires, gold increasingly became a symbol of economic and military power. And then human history entered periods where just a rumor of gold was enough to drive entire societies insane. California in 1848 is the perfect example. When gold was discovered at James Marshall's sawmill, everything changed almost overnight. Hundreds of thousands of people poured into the American West, hoping to change their lives. Cities sprang up extremely fast. Roads, banks, and trade systems exploded in growth. The California gold rush was not just a story about gold. It helped shape the history of modern America. What always makes me laugh is that nuclear reactions that occurred in dead stars billions of years earlier ultimately influenced the political map of Earth. But the story does not stop there. For many centuries, gold also became the foundation for the global financial system. The so-called gold standard basically meant that currency was linked to the amount of gold a nation owned. This idea created a feeling of stability because gold is rare and hard to fake. A banknote had value because people believed it could be exchanged for real gold. Think about that for a moment. The entire modern economy was once built on faith in an element born from ancient star explosions. And at a deeper level, this shows that humans have always associated gold with durability and trust. A piece of paper can burn, a government can collapse, but gold is still gold. That is why, in times of crisis, people often turn back to gold as if it represents something more stable than the entire political system around them. What I like most about this entire story is the strange connection between cosmic physics and human history. An element created from stellar catastrophes directly influenced trade, war, empires, and civilization. But it is also right here that the story of gold begins to reveal its dark side. That dark side appears very clearly in 1532, when Francisco Pizarro, along with fewer than 200 Spanish soldiers, marched into the Inca Empire. What makes this story almost unbelievable is that the Inca at that time possessed one of the greatest civilizations on Earth, with millions of people and a road network stretching across the Andes. But then that entire world began to collapse in an extremely short time. When Pizarro captured Emperor Atahualpa at Cajamarca, one of the most famous offers in history was made. Atahualpa promised to fill an entire room with gold in exchange for his freedom. Not a few small bags of gold, a large room nearly as high as a man. The Inca brought gold from all over the empire. Golden god statues, golden ritual objects, artworks crafted over many generations. They filled the room in a desperate effort to save their emperor. And here is the part that always makes me feel both strange and sad. The Inca did not view gold the way Europeans viewed it. To them, gold was a sacred symbol of the sun. It was connected to the gods, rituals, and the spiritual order of the world. The Coricancha temple in Cusco was covered in gold, not to show off wealth, but to reflect the light of the sun god. But the Spanish saw all of that in a completely different way. In their eyes, gold was mainly metal that could be melted into bars, coins, and power. They did not see a civilization trying to preserve its spiritual meaning. They saw treasure. And then one of the most heartbreaking things in history happened. Many golden artworks of the Inca were melted down into anonymous metal blocks. God statues, ritual objects, and religious symbols were lost forever, just to be turned into more easily transportable gold bars. Think about that for a moment. Objects created with sacred meaning over many generations were ultimately destroyed because of greed. This always makes me think that gold is actually neither good nor bad. It only reflects what humans want to see in it. For the Inca, gold represented the sun and the sacred. For the Spanish Empire, it represented power and wealth. The same metal, but two civilizations saw it as two completely different things. And that is probably true for all of human history. Gold both built civilizations and helped destroy them. It drove trade, art, and science. But it also drove war, conquest, and greed. There are cities that rose because of gold, and cultures that disappeared because of gold. What I have always found interesting is that all of this began from an element born in ancient star explosions. Physics created gold, but human psychology decided its meaning. Nature attached no moral value to gold. Gold is simply atoms with 79 protons created in the extreme events of the universe. But when those atoms enter the human brain, they become symbols of the divine, of power, of ambition, and sometimes of destruction. That makes me think a lot about how humans assign meaning to matter. A gold atom does not know whether it is sitting in a king's crown or in the circuit of a computer. It does not know if it is being used to build a temple or to fund a war. All meaning comes from us. And perhaps that is the strangest part of the entire story. Atoms created in cosmic violence ultimately became a mirror reflecting human nature itself. If a civilization sees gold as a symbol of beauty and the sacred gold reflects that, if an empire sees gold as a tool of conquest, gold also reflects that. Throughout history, the same metal has represented both wonder and cruelty. Some people look at gold and see the light of the sun. Some people look at gold and see only power. And honestly, I think that is why the story of gold is much more interesting than just a simple chemistry or astronomy lesson. It is a story about how a tiny element can connect nuclear physics, the evolution of stars, and the deepest psychology of the human species. Because ultimately, what is most important about gold may not lie in the metal itself, but in what humans see inside it. Perhaps the strangest thing about gold ultimately does not lie in its chemistry or its rarity. What truly obsesses me is the way gold connects completely different scales of reality. Think about this for a moment. A small ring on a human hand can connect directly to the most violent events that have ever occurred in the universe. The gold atoms inside it may have been born from the collision of two neutron stars billions of years ago. That means a tiny object that humans wear every day actually carries within it the history of ancient stellar catastrophes. I have always thought this is one of the most beautiful things science has ever discovered. The universe is not divided into separate parts the way our intuition often thinks. There is no absolute boundary between astronomy, physics, geology, and human history. Everything is connected. A gold atom is created in the chaos of a star explosion, wanders in space between the stars for millions or billions of years, becomes part of the cloud that formed the solar system, and finally appears in a civilization on a small planet orbiting an ordinary star. When you truly think about that entire journey, every object around us begins to feel much more profound. A gold atom can exist longer than almost everything humans have ever built. Empires appear and disappear, languages change, species go extinct, but that gold atom continues to exist. It may have passed through many star systems before becoming part of Earth. And what I have always found interesting is that humans often think they stand outside of nature, as if we are merely observers of the universe from the outside. But physics shows the opposite. We are part of the universe's history. Every atom in your body carries a story far older than all of human history. The carbon in your muscles was once created in the cores of stars that died before the sun existed. The calcium in your bones was once born in ancient star explosions. The iron in your blood once lay in the heart of a giant star. And gold is the same. That means the human body does not just live in the universe. We are literally made from its history. This is why I have always thought science does not make the world less wonderful. It only replaces simple stories with stories that are far more profound. Ancient people looked at gold and thought it came from the gods. Modern science says gold was born in neutron star collisions and supernovae. Honestly, I do not find this new story any less wonderful. In fact, it is much stranger. The idea that a small ring on your hand was created by events that bend space and time out there in the universe sounds even more astonishing than any myth. What I like most is that all of this could only be discovered thanks to human curiosity. Our brains evolved to survive on the African savanna, avoid predators, and find food. They were not designed to understand neutron stars or nuclear physics. But somehow, through mathematics, observation, and imagination, humans can still see through the ordinary appearance of the world and recognize connections so deep they are almost unbelievable. A tiny creature living on the thin crust of a rocky planet can understand at least something about how the universe creates gold. That alone is enough to amaze me. And the deeper you go into physics, the more you realize reality is much stranger than ordinary intuition. Space and time can curve. Atoms are mostly empty space. Electrons can behave like waves. Matter can turn into energy. The elements that shaped human history were created in giant stellar catastrophes billions of years ago. None of this story resembles the common sense that the human brain expects. But that is exactly what makes science so beautiful. It continuously forces us to abandon the feeling that the world is simple and familiar. And perhaps that is why humans from very early on always felt that gold does not belong to Earth. In a sense, they were right. Gold was not really born here. It came from places far more extreme, far more ancient, and far stranger than anything human civilization has ever created. That is also why every time humans discover a new gold deposit, entire societies almost go insane. Not many materials in history have ever had such psychological power. In 1848, a carpenter named James Marshall discovered small pieces of gold at Sutter's Mill in California. And almost immediately, the whole world began to move. The news spread so fast that within just a few years, hundreds of thousands of people from everywhere poured into the American West. Some crossed oceans by ship for months. Some crossed the continent by wagon under extremely dangerous conditions, all just for the hope of finding a few ounces of gold. What always amazes me is how gold can change human behavior almost instantly. San Francisco, before the gold rush, was just a small town with a few hundred residents. But then the population exploded to tens of thousands in an extremely short time. Cities sprang up almost overnight. Banks appeared. Roads were built. Goods flooded in. The entire economy of the American West was restructured just because of some gold atoms lying underground. The funny thing is that most of the people who rushed into the gold rush ultimately did not become rich. Many lost money, lost their health, or died on the way. But the psychological pull of gold was so strong that it hardly seemed to matter. As long as there was a chance to change their lives, people were willing to bet everything. And California was not the only case. The same thing repeated in Alaska, Australia, and South Africa. Every time gold was discovered, society entered a state almost like a collective frenzy. New cities appeared, populations migrated en masse, governments changed policies, entire regions became chaotic because of the hope of getting rich. This makes me think that gold has never been just a metal. It is an extremely powerful psychological force acting on human civilization. There is something in the human brain that reacts to gold in an almost instinctive way. Maybe because it is rare, maybe because it shines like sunlight, maybe because it is almost never destroyed over time, or maybe because of all those things at once. But whatever the reason, gold has become the center of economic power for most of human history. Banks were built around gold. Governments hoarded gold as a symbol of national stability. Massive financial systems existed based on the belief that gold represented real value. For many centuries, owning gold was almost synonymous with power. A king with more gold could build a larger army. A nation with more gold could influence global trade more strongly. This creates one of the strangest paradoxes I can imagine. An element born from neutron star collisions and ancient cosmic catastrophes ultimately controlled the behavior of millions of people on a small planet. Think about that. Nuclear reactions that happened billions of years ago ultimately influenced war, migration, politics, and the economy of humanity. There is something almost surreal about that. And the more you look at history, the more you see that gold did not just impact the economy, but also human imagination. Stories about golden cities, secret treasures, or people who found gold and changed their lives appeared everywhere. Almost every culture has myths related to gold. That shows its appeal goes much deeper than mere material value. A small lump of gold is almost useless if you only think about basic survival needs. You cannot eat it. You cannot drink it. You cannot use it to stay warm. But humans are still willing to cross oceans, fight, and sometimes kill each other just to possess it. That means gold is touching something very deep in human psychology. And honestly, I think that is the most interesting part of the entire story. Physics created gold through the most extreme processes in the universe. But it is the human brain that turned it into a symbol of power, dreams, and ambition. If you think deeply enough about that, gold is like the intersection point between cosmic physics and evolutionary psychology. An element born in ancient steppe islands, it ultimately became something that made civilizations change course. And perhaps the most fascinating thing is that humanity's fascination with gold has never really disappeared. Why do humans react to gold more strongly than almost any other material in nature? Think about this for a moment. A small lump of gold cannot keep you alive any longer than a loaf of bread. It does not help you breathe, does not help you stay warm, and did not have many direct uses for most of human history. Yet for thousands of years, almost every civilization has viewed it as a symbol of power, divinity, and immortality. That means the human reaction to gold is not entirely logical in the simple sense of survival. It touches something much deeper in our psychology. Part of the answer may lie in the way gold reflects light. The light from gold has a very special warm hue, almost like the color of the sun at sunset or firelight. The human brain evolved for hundreds of thousands of years under sunlight and beside fire. So perhaps we react to the color of gold in an almost instinctive way. Some psychologists even suggest that humans have been attracted to shiny objects since prehistoric times because they reminded us of water. In dry environments, the reflection of light on water was a sign of survival. That means our brains may have been programmed to pay attention to sparkling surfaces long before civilization appeared. And then gold appeared as the perfect material to trigger that response. It shines, it is rare, and it almost never loses its appearance. What is interesting is that gold is not so rare that no one finds it, but not common enough to become ordinary. If gold were millions of times rarer, humans would probably almost never see it and would not build civilizations around it. If gold were as common as iron, no one would consider it precious. But nature created gold at exactly the level that made it the perfect symbolic object for status. You can own it, but not easily. And that is extremely important to human social psychology. For most of history, owning something rare was synonymous with power. But gold has one other special advantage. It does not rust. A bar of iron left for hundreds of years will corrode. A wooden object will rot. But gold stays almost unchanged. This creates a very strong feeling of permanence in the human mind. Ancient civilizations saw everything around them gradually destroyed by time, while gold seemed to stand outside that law. It is not hard to understand why they began to associate it with immortality. The Egyptians used gold in the tombs of the pharaohs because they believed it was connected to eternal life. The Inca viewed gold as the sweat of the sun. Almost everywhere, things that were not destroyed by time were seen as connected to the divine. And honestly, I think most of that stems from humans always fearing disappearance. We know we age. We know our bodies will die. We know cities will eventually collapse. So a material that almost never changes over time creates a very special feeling. From the Egyptian pharaohs to modern financial buildings on Wall Street, gold has always been associated with stability and durability. Even in the digital age, when currency is mostly just data and computers, nations still hoard gold as a kind of psychological anchor for value. That shows the symbolic power of gold goes much deeper than its practical uses. And perhaps this is the most interesting part. Humans often project their deepest desires onto matter. We do that with flags, with monuments, with crowns, and with gold. A lump of gold by itself has no ambition, power, or divinity. It is simply a collection of atoms with 79 protons. But the human brain turns it into a symbol for almost everything we crave. Wealth, power, immortality, success, security. That makes gold like a perfect screen for humans to project their dreams onto. And this is what I have always liked about science. It shows that the boundary between physics and psychology is much thinner than it appears. Physics created gold in ancient star explosions. Chemistry makes gold not rust. Relativity gives it its characteristic yellow color. But it is human psychology that creates the obsession with gold. Without the human brain, gold would just be a rare element floating in the universe. It is we ourselves who turned it into a symbol of power and dreams. So ultimately, the story of gold is not just a story about astronomy or nuclear physics. It is also a story about humanity itself. Most people look at a gold ring and only see a small shiny object. But if you look deep enough, you begin to realize that object connects directly to the most violent phenomena in the universe. It connects with supernovae, with neutron stars, and with the very structure of space and time. The gold atoms in that ring once experienced temperatures of billions of degrees and pressure greater than anything that has ever existed on Earth. They were born in moments when matter was almost crushed to the final limits of nature. Then afterward they were blasted into space between the stars at terrifying speeds, wandering for millions or billions of years in the darkness of the universe before the solar system was born. That means the gold in banks, in watches, or in people's wedding rings is actually older than Earth itself. Think about that for a moment. A gold atom may have existed before this planet formed, before the oceans, before the atmosphere, before life. And then somehow, after that nearly unimaginable journey, it ended up in human hands. This is what I have always found most beautiful about science. It shows that humans do not stand outside the universe as separate observers. We are direct products of the universe's history. Every atom in your body also carries an ancient story just like gold. The carbon in your muscles was once created in the cores of dead stars. The oxygen you are breathing was once cooked in ancient fusion reactions. The calcium in your bones was once ejected from star explosions billions of years ago. That means the human body is actually a living collection of astronomical history. We do not just live in the universe. We are made of it. And the more I understand that, the more I see that science does not make reality any less wonderful. Many people think science is like a process of dismantling every mystery until the world becomes dry and cold. I have never seen it that way. In fact, the opposite is true. The deeper you explore, the stranger the universe becomes compared to ordinary human imagination. Ancient people looked at gold and thought it carried something divine. Modern science says gold was born from neutron star collisions that can shake the very structure of space and time. Honestly, I find this new story far more astonishing. The idea that a small wedding ring on someone's hand was created by ancient stellar catastrophes sounds closer to cosmic poetry than physics. What I like most is that all those connections were only discovered thanks to human curiosity. Our brains were not evolved to understand neutron stars or quantum mechanics. They were evolved to survive on the savannah, find food, and avoid predators. But somehow, through mathematics, observation, and curiosity, humans can still see through the ordinary appearance of the world and recognize connections so deep they are almost unbelievable. A tiny creature living on a small rocky planet around an ordinary star can understand at least something about how the universe creates gold. That in itself is almost miraculous. And the deeper you go into physics, the more you realize reality is much stranger than common sense. Space and time can curve. Atoms are mostly empty space. Particles can behave like waves. Matter can turn into energy. The elements that shaped human history were born in ancient star explosions. None of this story resembles the intuition that the human brain expects. But that is exactly what is most wonderful about science. It continuously forces us to abandon the feeling that the world is simple and familiar. The deeper you explore, the stranger the universe becomes. And perhaps that is why humans from very early on always felt that gold does not belong to Earth. In a very real sense, they were right. Gold was not born here. It came from places far older, far more violent, and far stranger than anything human civilization has ever created. The best way to end this entire story is to go back to an ordinary gold ring lying on a table under the light. Most people look at it and only see jewelry, or they see money, wealth, or status. But what always fascinates me is that almost no one realizes the real history inside that small object. Because that ring did not begin its story on Earth. It was not born inside this planet. The gold atoms inside it once passed through supernovae, once existed in neutron star collisions, and once experienced the most extreme conditions the universe can create. Before any oceans existed on Earth, before the dinosaurs, even before the sun, those atoms had already been wandering in space between the stars for millions or billions of years. That means the ring on a person's hand is actually older than almost the entire history of civilization. Think about that for a moment. Empires appear and disappear, languages change, cities are buried, species go extinct. But that gold atom continues to exist. It may have passed through many different regions of the galaxy before becoming part of Earth. And then through a nearly unimaginable chain of events, it finally ended up in the hands of a tiny creature living on a rocky planet around an ordinary star. This is what modern physics continuously shows us. Every object around you is connected to the history of the universe in a way far more profound than ordinary intuition. There is no real boundary between us and the universe. We are part of it. The gold ring is simply the most visible example of that. It is like tangible proof that humans are truly made of stardust, not in a vague poetic sense, in a completely literal physical sense. The carbon in your body was once created in ancient stars. The oxygen in your lungs was once born in fusion reactions billions of years ago. The calcium in your bones was once ejected from giant star explosions. And gold is the same. That means every human is a small living part of astronomical history. And honestly, I have never understood why some people think science makes the world less wonderful. To me, the opposite is true. In the past, people thought gold was a gift from the gods. Modern science says gold was created in events that can bend space and time. Honestly, I find this new story far more astonishing. The idea that someone's wedding ring was born from the collision of two dead star remnants out there in the galaxy sounds closer to a cosmic myth than physics. But that is what is best about science. It continuously shows us that reality is much stranger than ordinary imagination. What amazes me most is not just the universe itself, but the fact that the human brain can understand part of it. Think about that. A primate species that evolved on a small planet can use mathematics and curiosity to explore events that happen millions of light years away. A brain created to hunt and survive on the savannah can ultimately understand neutron stars, nuclear physics, and the origin of gold. That alone is enough to make me find it almost unbelievable. And perhaps the most important thing science has ever given humanity is not technology or machines. Perhaps it is curiosity. It is curiosity that keeps humans from accepting the world as only its appearance. One person looks at a gold ring and sees jewelry. A scientist looks at the same object and sees ancient star explosions, sees nuclear reactions, sees relativity, sees the history of the galaxy, and sees the psychological history of the human species. That makes the world much more profound. And the part I like most is that this story is not over yet. Out there in the universe, right now, nature is probably still creating new gold atoms. Somewhere in the darkness between the stars, two neutron stars may be orbiting each other faster and faster before crashing to each other in a collision so violent it shakes the structure of space and time. New gold atoms are born, blasted into space again, and perhaps billions of years later become part of planets and civilizations that do not yet exist. That means the story of gold is not just the past. It is still continuing. And perhaps that is what I have always loved most about the universe. It is always bigger, stranger, and more interesting than anything common sense has ever told us. The deeper you explore, the more you realize reality is not as simple as it appears. A small ring on the table can contain the entire history of dead stars inside it. An element that once drove civilizations insane was actually born from ancient cosmic catastrophes. A small brain on a small planet can understand at least part of that entire story. And to me, that is the real wonder. If you like science stories that make the world stranger and more wonderful, please subscribe to the channel so you do not miss the next journeys exploring the deepest secrets of the universe. And the next time you look up at the night sky or look at a small gold ring, perhaps you will remember that the entire universe is hidden inside the most ordinary things around us.